Your computer does not understand what google.com means or where it lives. It only understands numbers. So who exactly translates these names to numbers? In order to learn that, we got to learn DNS. You see, in the earlier days of the internet, computers used to interact only with each other. And at that time, having these IP addresses or remembering these numbers was completely normal. But it became a problem when computers started interacting with humans, because imagine remembering 20 websites, each with different IP addresses, which also change over time. This was the first problem statement for us. The internet required a system that would allow users to remember names only, and the computers would still receive numbers. And that gave birth to DNS. You can call DNS as servers, but I would say it is a global agreement or a system that agreed to map names to numbers. When you type out www.google.com, your computer does not know magically where google.com exists, so it starts asking questions. But first, it starts asking questions locally, because asking the internet would make it a slow procedure. Let's start with the first place your browser usually looks at, the local memory. It's also known as caching. If you opened google.com 5 minutes ago, your browser knows the IP address of google.com or the website you're visiting, and hence the DNS ends there. If not, your browser asks your operating system. Yes, your OS also keeps a small amount of memory of past DNS answer, so your website loading becomes quicker. But if there's still no answer, your request finally leaves your device. The second place of search happens at the DNS resolver. It could either be the Google DNS resolver or the Cloudflare DNS resolver. The main job of the DNS resolver is to keep you assured that it's going to get you the IP address that you're looking for no matter where it is. Either it's going to provide it to you, or it's going to move forward the DNS request to other DNS servers in order to get it for you. The way your browser was frantically searching for the IP address locally before, your request is going to search for the IP address in these DNS resolvers. If the answer is not present there, if the correct IP address is not received in these DNS resolvers, the DNS request is carried forward to the other servers. Now you might be wondering, why does one server does not have everything at once for us to search and receive? Why do we have to travel so much over the internet in order to get a simple IP address for a website? And the answer to this is the DNS is layered. It has to be a hierarchical structure so that one server is not responsible for all the IP addresses and all the requests coming from all the people from around the world. If there was only one server responsible for all of this, the DNS server would crash, it would be hacked, and it would be too slow, and nobody would be able to work the way they want to work. Now starts the next phase of our search. We did not find the IP address locally, we did not find the IP address in any of the DNS resolvers. We have finally reached, or the request has finally reached, the root servers. So the root servers are actually at the top of the triangle of the DNS hierarchical structure, and they are not going to be dealing with your teeny tiny requests. They are just going to be telling you one thing. So if your website name has a .com or a .in or a .org and so on, it's going to tell you which servers are responsible for .com, which servers are responsible for .in, which servers are responsible for .org, and so that your search narrows down and it becomes easier and quicker to find the IP address to your website. So here, since we are searching for www.google.com, the root server is just going to let you know that for .com, please refer to the .com servers, and it's going to display a list of names of the servers that you can go and visit. Now just taking a moment to make it clear that you are physically not traveling through these servers. The only thing that's traveling and getting the information from these servers and moving ahead with the search is your request. So that is going to move forward to a .com server now. Now we have reached one of the .com servers. Since it only takes care of .com domain names, hence it's also known as a top level domain server, because the .com part or the .in part of your website name are called top level domains. Now the question is, does your top level domain server know the exact address or the IP address of www.google.com? It again is a superior level server, and it will not give you the IP address or will know the IP address of the entire website. What it's only going to look at is google.com. Now, since .com is already resolved and we have narrowed down our search here, Google is the word that we're going to looking into next. Google google.com, or the word Google here, is nothing but the second level domain. So now the top level domain is going to let you know which server or which authoritative server takes care of google.com, and your search narrows down further here. Now the authoritative server that we have reached to is owned by Google, and it is the only source of truth that knows where www.google.com resides, and it gives you the IP address. The IP address reaches your device, and now you can finally load whatever website you were looking for. Taking a moment to familiarize you with different parts of a website name or a domain name. The .com or the .in part is the TLD. The one that is noted as Google here is the second level domain, and the www. That part is the subdomain. The authoritative servers look at www.com because for google.com the search was already narrowed, which led us to the authoritative servers. So now it gives us the IP address of the entire domain name, and we can load it on our screens. It has something known as the zone file, which has all this information noted down along with few other instructions on how to reach a service. That is exactly what gives us the IP address. Now, every time you visit a website, if the DNS lookup has to go through this entire procedure, the internet would be incredibly slow. Hence, caching came into picture. But again, caching forever can also become dangerous, because if you're storing something forever, that means attackers can get access to it. And we are also accustomed to the fact that IP addresses keep changing, so we cannot store anything forever. This is exactly why something known as the TTL came into picture. TTL stands for time to live, and a TTL is always specified whenever we are caching something. Once the time to live, or that number of seconds, or that amount of time is over, the cache refreshes itself and the resolver has to ask again. This balances both speed and accuracy for us. So yeah, we learned about how the entire search traverses over different servers in order to get your IP address, and you can finally load your web page, and for how long your answer is cached until you have to make that entire traversal again. In the next video, we are going to be discussing about DNS records, which is also a very important topic, and at the same time it was a part of the zone file which was provided to us by the authoritative DNS server as the last step of our search. Until then, let's learn, let's stay curious, and let's keep exploring the wonderful thing that networking is.